Here's another dynamic video, number 4, in our lesson planning. And I'm going to start with a question where I want to show you how on AP exam you may have many questions where the numbers are not given, but you have to derive a formula. So in the diagram, a box of mass M is sliding down the ramp of the length L. So the information is given, the length of the ramp is L, with an incline of theta with a horizontal. The mass slides down the ramp with kinetic friction is given. If released from rest, so initial velocity is 0, at the top of the ramp, what is the expression of the velocity of the block at the bottom of the ramp? So I'm going to start with the forces acting on the block. So I have the force of gravity, mg. I have the normal force, and I have the friction force. And I'm gonna choose my new axis, x and y. So my y is gonna be aligned with the normal force, and my x is aligned with the horizontal. And because it's sliding down, there is acceleration. They didn't say it's moving at the constant speed, so there is some acceleration. My positive direction is going to be with acceleration, and my positive direction on y is going to be up. So now I'm going to draw the components of the vectors that do not align with the horizontal and vertical, which is force of gravity. So it's this one. Let me see which color is easier to see. Maybe this. I have this vector and this vector, and if you remember, this angle theta is right there on the top of that triangle. So I have mg cosine theta, and the bottom one is, the horizontal one is mg sine theta. Now I'm going to do the Newton's second law, where the sum of all the forces, the net force, is equal to ma on x-axis and then on y-axis. So on x-axis I have mg sine is in the positive direction, aligned with the direction of acceleration. So I have mg sine theta positive, and friction is negative. And horizontally it does accelerate, and I chose acceleration to be to the left positive, so that is ma. On the y-axis, I have the normal force in the positive direction, and I have mg cosine in a negative direction, mg cosine theta. And there is no acceleration vertically, so I'm going to say equals to 0. Or, so I don't have to write this whole thing one more time, I just move mg cosine to the other side of the equation and say the normal force is equal to mg cosine. So now I have this equation, and I have to find the final velocity at the end of the ramp. So I need to figure out my acceleration. I'm going to use the normal force to plug it into the friction force, because the friction force has a formula, mu times n. So I need that n for my friction force. So my final formula is going to be mg sine theta minus the friction, which is mu mg cosine theta, and that is equal to ma. All of them have all three terms. So I have one term, and then the sign negative, another term, and then the sign equals to, and the third term. All of them have mass, so I'm going to cancel the mass from every single one of them. And I figure out the formula for acceleration. So let me write it maybe in different color. So acceleration is equal to, I'm going to take g out, g sine theta minus mu cosine theta. So this is my acceleration. And I also know the distance is given. The distance is L. And they call it mu kinetic, so I can just put kinetic friction. description right there. And they give you the length. So I know the acceleration and I know the distance. They give me the length of the incline. So I can find the final velocity with the square root of 2AD. So I have the square root of 2 acceleration and the distance. And here is your final solution. So many times on AP exam you will not be given any numbers. You have to be able to derive the formula, and so you have to learn to derive the formulas, and you only learn deriving this type of questions and formulas by practicing. You have to solve practice questions, and it's all about Newton's law. It's always about writing the free body diagram and then plugging in the variables and manipulating the variables to solve for the variable that they ask you to. Here's another question. The mass M1, the one that is on the left, is 2 kg, and the mass M2, the one that is on the right, is 4 kg, and the angle with the horizontal is 54 degrees. Draw the free body diagram and for both objects. Find the acceleration of the objects and the tension in the string. Find the displacement of each object of 1 second after being released from rest. So the free body diagram, on the one on the right, on the left, I have M1G and I have tension force. And because it's the same rope, the tension is the same in this rope. So the tension up for the incline object is the same tension. The normal force is perpendicular to the surface, and the force of gravity, M2G. Then I have to do to align them with the axis that I'm going to choose. And because 4 kg mass is heavier, I'm going to say the acceleration is going to be this way. If I guessed it wrong, then I'm just going to get negative acceleration as my answer. So guessing is okay. And so I'm aligning my axis, horizontal and vertical, with my acceleration. So I have to switch my axis again. And your angle theta is right here. And if you don't understand why this is the angle theta, you have to go back and watch, I believe, the video 2, Dynamics 2, this is where I explained it for the first time. 2 or 3. So the one that is adjacent to the angle is going to be mg cosine, and the one that is opposite of the angle is going to be mg sine. So then I have to write the equations. F is equal to ma, so it's always about Newton's second law, that the sum of the forces, or the net force is equal to ma. So it's always after the free body diagram, we have to write these equations. And also it says it's frictionless pulley, and the incline is also frictionless. So I'm gonna write for mass 1, M1, the net force formula, and for mass 2. So I'm gonna have again system of two equations. For mass 1, I have the tension is up and M1G is down, and acceleration is up, so that is positive. For my second mass, the first I'm going to write with the acceleration because the other two cancel each other, the vertical ones. The normal force is mg cosine, cancel each other, or I can write it here. So for the second mass, the normal force minus m2g cosine theta is equal to 0 because there is no forces acting vertically on the mass. So those two forces cancel each other. Or in other words, I can say that normal force is equal to m2g cosine. So if I move m2g cosine to the other side, I can say that the normal force is equal to m2g cosine. And then for the horizontal forces, I have one that is aligned with the x-axis, with the acceleration, so that is m2g sine, and the other one is the tension force. So the tension force is negative, so I'm going to write the first one m2g sine, m2g sine theta minus the tension force is equal to m2a. And because I don't have friction, I don't really need my normal force. Now I'm going to solve for tension and then plug in that tension. So I'm going to solve for tension and replace this tension with wherever I'm going to solve for. So the tension is equal to m1g plus m1a. So if I plug it in now, I have m2g sine theta minus, and I have to subtract both of those, so this positive sign will change to a negative. So I have m1g minus m1a, because when I drop the parentheses, because I have a negative, when I drop the parentheses, that sign will change. So I have to have a negative right here, and equals to m2a. So now if I move all a's to one side, I will factor out a. So I have m2 plus m1, and on the other side I can take g out. What's left is m2 sine theta minus m1. So acceleration is equal to g, and I have m2 sine theta minus m1, and then m2 plus m1, and that will be equal to, I have 2.06 meters per second squared. So I found acceleration. Now, so I did the first one, the free body diagram, AA. B found acceleration. Now I have to find tension. So to find the tension, all I have to do is just plug it into my tension formula. So I have tension is equal to, I can take m1 out, which is 2. So let's write the formula instead. So I have m1 is out, and I have g plus a. So that gives me 2 kilogram, 10 plus 206, and that gives me 2412 newtons. So that's the tension in the rope. And the last part, they ask you to find the displacement if it traveled over 1 second. So if you know acceleration, it started from rest, the final velocity is going to be initial velocity, which is 0, plus acceleration, which is 206, times the time 1 second. So that gives you just 206 meters per second. And if you want to find the distance is average velocity times the time. If initial velocity is 0, final is 206, the average is 103, and the time is 1 second. So the distance traveled is 103 meters. Here's one more new type of a question. So we have a block of 2 blocks on both sides of the inclines. Their angles are 30 and 60 degrees. They give you that there is a frictionless pulley of radius 0.15 meters. You don't have to worry about that information, it's just extra. 2 masses, 8 kilogram and 10 kilogram, and you have to determine the acceleration and the tension in the string. So again, you start with the free body diagram. So we have the tension, we have the force of gravity, I'm going to call it m1g, and we have the normal force. And for the only one force that is in, it's frictionless incline, so you don't have to worry about the friction here. So we're gonna break the forces into vertical and horizontal for mg, so they are aligned with the direction of our acceleration. So acceleration is going to be my x-axis, and the normal force is going to be my y-axis, and 30-degree angle is going to be right here. That is 30-degree angle. So your vertical component is mg cosine, and your horizontal component is mg sine. Then for the next mass, I have the same. I have the tension. So here is the tension. It's the same rope, so it's the same tension. The M2G force and the normal force. Let's call this one N1, and this one is M2. Then I have an acceleration is going to be in this direction. So this is my acceleration. Then the components of the force of gravity are going to be mg, because this will give the angle, so this is mg cosine, and the one that the opposite of the angle is mg sine. Okay, so now I have to write the equations, the net force for each mass. So my direction is always going to be positive, the acceleration direction. So for the first mass, I have my vertical forces. I don't care about them because I don't have friction, so I don't care what my normal force is equal to. So I'm just going to ignore my N1 and N2. I don't have to worry about my N1 and N2 at all. Only when we have friction force, we need our expression for N1 and 2. So what I have here is the tension force, which is positive, minus mg sine, m1g sine theta, and that is equal to ma, 1a. And for the second equation, I have tension, which is opposite of the acceleration, so it's going to be negative. And what I have there is m2g sine theta minus the tension is equal to m2a, because I chose my direction to be positive with acceleration, and tension was in the opposite direction. So now when I did that, I'm going to solve for tension, and again plug it in instead of tension. So if I do this, I have m2g sine theta minus, and now I have to do wherever tension is equal to, and the tension is equal to m1g sine theta plus m1a, and all of that is equal to m2a. So wherever is my parentheses is my tension. If I drop these parentheses off, so if I drop the parentheses, this negative sign in front will change the sign in the middle right here. So this sign will become a negative, and the parentheses are gone. Now I'm solving for acceleration, so I need to move my acceleration to the other side. So on this side, I can take g out. So g is out, and what I have is m2 sine theta minus m1 sine theta, and equals to, I'm going to move m1a to the other side and take acceleration out, and I have m1 plus m2. So now my acceleration is equal to g. Then I have, when there's theta 1 and theta 2, I should have mentioned this. So for m1, it's going to be theta 1, and for m2, it's theta 2. So for m1, I have theta 1, and for m2, I have theta 2. So m2 has theta 2, and m1 has theta 1, and m2 has theta 2, and m1 has theta 1. So I forgot about that part. Sorry. So now I'm going to plug it into acceleration. So acceleration is equal to g. I have m2 sine theta 2 minus m1 sine theta 1, and divided by m1 plus m2. And that will give me, and after I plugged in the numbers, I got 5.8 meters per second squared. To find tension in the string, I just plug it into one of the formulas. I'm going to choose the first one. So your tension is equal to, I'm going to take m1 out, and I have g sine theta 1 plus acceleration. So that gives me 86.4 newtons. Let's do this question too. Two objects connected by a light string passing over a light frictionless pulley. The mass of one is 5 kg and the mass of the other one is 3 kg, and the height that the mass one is released from is 4 meters. Determine the speed of each when they pass each other. Determine the speed of each by the time the M1 gets to the bottom of the floor, and how much higher M2 will fly after M2 is already on the floor. So first I'm going to do the free body diagram. So I have M2G, and I have tension, and then I have M1G, and I have tension. So the acceleration is going to be down for this mass, and the acceleration is going to be up for this mass. Then we're going to use the net force is equal to ma. So for the first mass, I have the tension minus m1g is equal to negative m1a, because acceleration in the negative direction. And for the second one, I have tension minus m2g, and acceleration is positive, so it's m2a. Now, if I solve for acceleration, I am going to have g m1 minus m2 and m1 plus m2. What you have to do, if you set it up t equals to each other, I think I did it in lesson for dynamics number 2, and then you set them equal to each other, so for the acceleration, and then your acceleration is going to be equal to 2.5 meters per second squared. So that was the answer for A. For B, determine the speed of each one at the moment when they pass each other. Because the height is 4 meters, they will pass each other when they both travel 2 meters. So I need to find the velocity when they both travel 2 meters. I have initial velocity 0, final velocity I'm looking for, and I just found what acceleration is equal to. So it's a that type of a question. So I have the final velocity is equal to the square root of 2, acceleration is 2.5, distance is 2 meters, and plus initial velocity squared. If you do not know how I get this formula, I would call it that formula. Go back to my lessons for kinematics, you will find it there. So we have square root of 10, which is equal to 3.16 meters per second. So I found this velocity. Now I need to find the velocity for the C part when the M1 reaches the ground. So I need a new velocity. So this is 1 halfway through velocity. And the new final velocity is the maximum velocity they will reach when M1 reaches the ground. So again, I have the distance and acceleration, so it's 2 times acceleration is 2.5, and the distance in this case is 2. So I will have the square root of 20. So I have the square root of 20, which is 4.5 meters per second. So when M1 reaches to the bottom or to the ground, M2 still has a velocity of 4.5 meters per second, or 447 meters per second. So they both have 4.45 or 4.5 meters per second when M1 reaches the ground. And M1 is stopping, but M2 still flies up at the velocity of, it's flying up at the velocity of 4.5 meters per second. It will take M2 the time of change of the velocity over the acceleration. So that gives me the time for it to stop is going to take 0.45 seconds. So only in 0.45 seconds, M2 is going to stop. So I can find to what height it will go, because the C part is where they ask you the height it goes to. I need the average velocity times the time. So initial velocity of M2 is 4.5. Final velocity when it stops is 0, divided by 2, times the time, which is 4.45. So the height to which it goes before it stops and falls down, 1.1 meters, 1 1/100 of a meter. This will be the end for this video, and there's one more video is coming, Dynamics 5, and I will see you in the next video.